Important formulae. Optical fiber. Critical angle theta c is equal to sin inverse n2 upon n1. Numerical aperture. Numerical aperture n is equal to sin theta naught is equal to square root of n1 square minus n2 square upon n naught. Numerical aperture fiber in air. Na is equal to sin theta naught is equal to square root of n1 square minus n2 square. Fractional index change delta is equal to n1 minus n2 upon n1. Calculate the numerical aperture and acceptance angle of an optical fiber having n1 is equal to 1.49, n2 is equal to 1.44. Therefore, formula is Na is equal to square root of n1 square minus n2 square. Angle of acceptance theta naught is equal to sin inverse numerical aperture. Given data n1 is equal to 1.49, n2 is equal to 1.44. Therefore, numerical aperture is equal to square root of 1.49 square minus 1.44 square. Numerical aperture answer is 0.38275. Angle of acceptance theta naught is equal to sin inverse numerical aperture. Sin inverse 0.38275. We had to calculate sin inverse in calculator. Theta naught is equal to 22.5 degrees. In an optical fiber, the core material has a refractive index 1.6 and refractive index of clad material is 1.3. What is the value of critical angle? Also calculate the value of angle of acceptance of the core. Angle of acceptance of the core. Given data n2 is equal to 1.3 and n1 is equal to 1.6. Critical angle theta c is equal to sin inverse n2 upon n1. Acceptance angle theta naught is equal to sin inverse square root of n1 square minus n2 square. Angle of acceptance of cone is equal to 2 theta naught. Theta c is equal to sin inverse 1.3 upon 1.6 is equal to 54.34 degree. Theta naught sin inverse square root of 1.6 square minus 1.3 square. Theta naught is 68.866 degree. Angle of acceptance of cone is 2 theta naught. 2 into 68.866. 2 theta naught is equal to 137.732 degree. A fiber cable has acceptance angle 30 degree and a core index of refraction 1.4. Calculate the refractive index of the cladding. N1 is given 1.4. Theta naught acceptance 30 degree. Sin theta naught is equal to square root of n1 square minus n2 square. Sin 30 is equal to square root of 1.4 square minus n2 square. Squaring both sides. Sin square 30 is equal to 1.4 square minus n2 square. n2 square is equal to 1.4 square minus sin square 30 degree. Therefore, n2 is equal to 1.3077. Calculate the fractional index change for a given optical fiber if the refractive indexes of the core and cladding are 1.563 and 1.498 respectively. Given data n1 and n2 are given. Fractional index change formula delta is equal to n1 minus n2 upon n1. Therefore, delta is equal to 1.563 minus 1.498 divided by 1.563. Therefore, delta is equal to 0.0416. Next problem. An optical glass fiber of refractive index 1.50 is to be clad with another glass to ensure internal reflection that will contain light traveling within 5 degree of the fiber axis. What maximum index of reflection is allowed for the cladding? As total interreflection takes place for light traveling within 5 degree of the fiber axis, the critical angle is theta c is equal to 90 minus 5 is equal to 85 degree. N1 is given 1.50. Sin theta c is equal to n2 upon n1. Sin 85 degree is equal to n2 upon 1.50. Therefore, n2 is equal to 1.4943.